again, DevConf. It's great to be here. I've had a great day. Have you had a great day? Yeah. So I've got the last session of the day. It's quite an uncomfortable position. I'm standing between you and a refreshing beverage. So I'll do my best. I'm Donald. I'm a software developer and consultant with Equal Experts. I've been involved in software development since the mid-90s, which I guess makes me quite experienced. And I've had a variety of experience. So I've taken on a number of roles. I've been a product owner, I've been an IT manager, I've been in test automation, I've written some terrible front-end code, I've been in architect roles, but I seem to keep coming back to back-end developer roles, which are the things I really enjoy. So the broad range of experience has given me the opportunity to be burnt in multiple places by software quality problems. I struggled to come up with the right name for this talk. So non-functional or dysfunctional. So what I'm trying to say is the way we deal with non-functional requirements is not helpful. It's dysfunctional. Starting with the name is not a great name. And so I'm asking us this afternoon not to leave it to chance. Let's be deliberate about these things. I'll tell a few stories. So my son turned 18 last year, and remembering how we used to lose our keys when we started driving, we bought him a Bluetooth keyring. And it was easy to install. He downloaded an app on his phone, connected it over Bluetooth, pushed the button on his phone, and it beeped so that he could find his keys. So we tested it, we had some fun, and then we left it. And then we were going out, and I said to him, "Find your keys." And he pushed the button on the phone, and nothing happened. The device had disconnected. The Bluetooth connection had been disconnected. So do you think we looked at each other and said, they seem to have missed some important non-functional requirements? No, that isn't what we said. What we said is, you had one job. So we sent this useless piece of plastic back to Takealot, wrote a terrible review, and said, we're never buying anything like this again. So this comes to the first of our key points, which I'm going to be hammering a bit this afternoon. So that wasn't a product. It was just a useless piece of plastic. And if we neglect quality requirements, if we neglect these things we like to call non-functional, maybe we don't have a functional product at all. I read some papers about software projects. And one paper had studied software projects that had succeeded and failed. And where projects had neglected non-functional requirements or ignored them, more than 60% of them had failed. Quite a lot more than the average. I'm sure none of you have had problems with software quality, but just so that I can show it's not only me, here are a few other stories. So 20 years ago, the US Defense Department invested $2.7 billion in a real-time intelligence system for people in the field, for troops in the field. It failed completely because it was unusable and had very poor performance, so they withdrew it. It had one job. You may remember Ashley Madison. It's a dating site with the tagline, "Life is short, have an affair." In 2015, a group of hackers called the Impact Team hacked into Ashley Madison and stole the whole database, including all the customers and contact details, and published it on the internet. The next day, the CEO resigned. He had one job, and then he didn't have a job. The SABC collaborated last year with the education department to produce an app for matric results. It had an unenviable low profile. The day before the results came out, it had approximately 0 traffic. The day after the results came out, it had approximately 0 traffic. But at 6:30, one Friday morning in January, tens of thousands of students were trying to get their results. I sent quite a few requests to this app, and they all timed out. It had one job, and it only needed to do it for a few hours. If you look at these stories, they all involve at least one of these things. So these are the old school non-functional requirements, 6 of them. Availability, security, modifiability, testability, usability, and performance-ility. We affectionately call them the illities. If you Google software quality, these things come up a surprising number of times. In the literature, there seems to be a correlation between software quality and these 6 things. But what do we call them? So we used to call them non-functional requirements. Dave Farley, in his continuous delivery set of videos, has one called non-functional requirements are stupid. So he doesn't think that the idea is stupid, but he definitely thinks that the name is stupid. And because it's a stupid name, it causes us to think in the wrong way about them. So we think they're non-functional requirements, and then they're functional requirements, and somehow the functional requirements are more important. But of course, if we don't get the non-functional requirements right, we don't have any functional requirements worth using. And that's the point that he makes. Mark Richards and Neil Ford, in their work on architecture, talk about architectural characteristics to refer to these things. If you're over the age of 35, you may recognize this. It's called a book. This book is called Software Architecture in Practice by Bass, Clements, and Kasman from the Software Engineering Institute, and it's had a big impact on my work. So they have a chapter in that book for each of those 6 things, and they call them quality attributes. We'll be coming back to that because I think they have some great ideas about how to think about these problems. So, but I eventually came down to quality requirements because I have this association in my mind between these 6 things and software quality. That I'll refer to them as quality requirements for the purpose of this talk. Can you shout out? You've been burnt by some of these things. What are they? A few others beyond those 6. Anybody? So I made a list. Sorry? All of them. No, this is a list that I came up with. So in the latest version of this book, the latest edition, they added accessibility, energy efficiency, integrability, deployability, and safety, and I added a few more random ones. So about 25 years ago, we were building an electronic banking system for home use. To give you an idea of how long ago this was, it was a downloadable, installable application. It wasn't a web app. When we were building it, we were obsessive about the security, obviously, and also the performance and the usability. We needed those 3 things. We got those things right, but we ran out of time for availability. And the day we went live, my colleague who'd built the back-end services left to work with another customer, and I was left holding the baby, quite a badly behaved baby. In the middle of the night, it would wake me up, as babies do, and I would drive across Joburg to try and understand why it had failed and restart it and get it going again. So we learned quite quickly about availability. We learned about load testing. We learned about performance testing. We hammered the thing and it fell over in the lab, and we were able to fix the problems. We redesigned it completely to make it more available. Its only job was to be available to people so they could do their banking. So then we learned to write requirement specifications, or software requirement specifications from a template. So this is a thing that took about 6 weeks to write. Well, that's how long it took me. And about 6 weeks to review and get it approved. And it always started easily with a few use cases and a few numbered functional requirements. And then you got to that part that everybody hated, called non-functional requirements, and you really scratched your head. I always copied and pasted from another document and then tried to think a bit more carefully about how those things applied to my product that I was working on. But at least we were forced to think about these things. So on one project, we were developing an implementation of SIP, which is the multimedia signaling protocol that you probably use every day without knowing it. We were implementing it on behalf of a customer in the US. And something unusual about this was that we were handing the code over to them, and they were handing the code over to their customers so they could compile it on their compilers and their cross-compilers and deploy it to their platforms like voice over IP phones and network equipment. So we worked hard on testing performance, testing that all the features worked. We even did interoperability testing with other vendors. And then we delivered the code to the customer. And the first thing they did was to compile it with a compiler that we hadn't tested with compiler settings that we hadn't used, and it failed. So that wasn't a good first impression. The next thing they did was to review the code, and they sent us a code review with a few innocent issues, and then this one. Please remove this comment from the code. Written after too much coffee and too little sleep. Use at your own risk. So before they'd even run a single test, we had created a terrible impression with them. And the message came back to us that the customer was puzzled that such a talented team could come up with such poor quality. And Agile came along to save us. So in Agile, we talked about user stories. User stories are kind of the starting point, the currency of Agile. And so that's how we work. We build small increments. We deliver in little bits. We design for the requirements that we know. We don't anticipate. The requirements we build only for those we know. And these are the good things about Agile that we like. But how are we going to deal with these quality requirements? So one of the things we tried was to build them into the acceptance criteria for the user stories. So this story requires this level of performance, this level of availability, this level of modifiability, etc. But it started to creak a bit because we were now coming up with new requirements, but what did we want to retrofit them to existing stories? We wanted consistency across the whole system. It was rare that we wanted a different level of availability in one part from another part, or one part to be very secure and another part could be less secure. One part could be testable and another could be less so. So we realized that there was a cross-cutting feeling about these requirements. And we had to come up with the cross-cutting requirements and define them in that way. And if we did that, the acceptance criteria tended to come out quite naturally for the individual user stories. So this is what we came up with, right? You've all seen this kind of thing. As an account holder, I'd like my banking app to be secure so that nobody steals my money. So I've spoken to a number of my colleagues, and I keep on asking them, have you ever seen a story like this? Obviously, I made up this one to be deliberately silly, but very few people have ever seen stories like this. We don't see them. In fact, they're not going to happen. So what do we get instead? Well, start a new project. We're excited. We plan. Get together, dream up new user stories, we put them into a story map. We think about how we're going to release them tentatively because we know we're going to iterate and change the plan as we go. And then we get to this point on the agenda called non-functional requirements, and we scratch our heads and look at each other blankly, and we say, let them emerge. They are what they are, to be decided. Let's go. And we go into our sprint one, or whatever we call it. We build, we implement, we test, we release, we repeat. We do that a few times, and then we get to this point where we're disappointed. And the disappointment often is expressed with this one word. Obviously, we need 4 nines availability. Obviously, this thing must respond within 200 milliseconds. Obviously, we need to be able to develop and test a feature in an afternoon. Obviously, we can't have some teenage dirtbag come and steal all our data. Obviously, this thing needs to be usable by a toddler. And this is a bullying word. And it works so well because these things are so obviously desirable. Who doesn't want more availability, more performance, better usability, more testability, etc.? And so we take it on and we feel bullied. But the reason that it doesn't make sense is that these things cost something. Availability costs you something. And as a responsible development team, we don't go and invest time, and more importantly, opportunity cost, where we're not building other things. We don't go and invest that time in features that haven't been planned by the whole team. So we get to the next of the key points. This isn't obvious. None of this is obvious. And we'll keep coming back to this idea. Another reason they're not obvious is that these things tend to interact with one another. They're not independent. So these things trade off. So there's the old trade-off between security and usability, which has become even more vicious with multi-factor authentication. So by the time you've done all 17 steps of your multi-factor authentication, you don't feel like, you can't even remember why you wanted to use the app, let alone know how to use it. So if we make it usable, we tend to make it more secure and vice versa. And performance tends to trade off against everything. So if we spend all our time encrypting and decrypting things to make things secure, our CPU is tied up with that, and our performance is worse. If we optimize our code to make it more performant, we often use algorithms that are less easy to understand, and we make the code less modifiable. The next one I'm particularly proud of is modifiability trades off with modifiability. So I worked on a code base, maybe you've seen code bases like this, where everything was a Java interface. So you're reading through the code, And you come to some point and you click through to the method and you see, oh, it's an interface. And there are 5 implementations of this interface, and you have absolutely no idea which one applies in the scenario that you're thinking through. So you give up and you start stepping through the code so you could understand. And so at one level, it's modifiable because you can extend it by implementing the interface in a new way. But at another level, you don't even know where to start because you can't read the code. Some of them are complementary. So if you have testable code, it often becomes more modifiable because you can make modifications knowing that you'll pick up problems quickly so you can go faster. If you work on accessibility, to make the code easy, or you make your app easy to use for people who are partially sighted or blind, you get some usability for those of us who can see. And often, if you work on responsiveness, you get a whole lot of usability included in the price. So these things are quite technical. Many of these things require technical input from us as developers. And so for us to expect that product owners and business analysts are going to be able to do this on their own is unrealistic. We need to help them to understand these trade-offs and to make informed decisions about prioritization based on them. We built a mobile app for in-store use. We were very happy with the usability, and the performance in the lab and in the cloud is pretty good. And then we took it into the stores and we did testing there. Now, the stores are big, and so the access to the mobile networks is patchy and slow. So the retailer put in their own Wi-Fi network, which was patchy and slow. So what we had was a completely different performance from the app in the store from what we had in the lab and in the cloud. So one of my colleagues turned to me and he said, "At least it's not our fault." And I said to him, "What do you mean it's not our fault?" And he said, "Well, it's not my job to know what's going on in the Wi-Fi networks." And I said, "Well, if we don't make it our job, it won't be your job, and it won't be anybody's job because there won't be a job, because there won't be a product." And this is why people love working with me. So the third point is, it's not my job. As developers, we need to be involved in this. A little bit more detail, not my job, right? So we as developers might say, this is a requirement. We're not responsible for requirements. We're responsible for design and implementation, and if you insist, testing. The product owner and the business analyst are responsible for requirements. But as we've seen, that maybe they're not able to analyze these requirements entirely on their own. They could definitely do with a bit of help from us. The architect is responsible for the requirements. This is an architecture textbook. Isn't the architect responsible? And of course, the architect does have an opinion on these things, but the architect doesn't work at the level of detail that we do with the code that we're working with, and we need to form our own opinion about these requirements. One of my favorites is a product owner who says, "Our developers are really good. They know what they're doing. They can work this out on their own. I never have to worry about quality." Or even worse, quality assurance, it's in the name. Surely it must be their job to worry about these things. And of course, the poor QA and developer come back to that investment in time. They're not making that decision on their own. It needs to be a team decision to decide that we invest in quality. So one version of this is technical debt. A product owner who says, "I leave plenty of time in the schedule for developers to work on technical debt." But it doesn't really make sense. So what is technical debt? It's when we compromise intentionally on some requirements, for example, performance and modifiability, so that we can achieve another requirement, usually a deadline. And we do it temporarily, and we keep a log of it, and we intend to pay it back. We pay back the debt. In other words, we undo the compromise over time. But if we haven't defined our performance and modifiability requirements, we can't define technical debt. So this argument boils down to, it's the developer's responsibility to figure this out and to decide what the requirements are. And developers, as we often say, we can trust the platform. If my app falls over, if my service falls over, Kubernetes starts it up again, and in the meantime, it redirects traffic to other nodes in the network, and there's no major harm done. Or we get security because the platform encrypts everything. Or perhaps we even get performance enhancements from the platform. But the problem is, what is the most insecure code? The least performant code, the least available code written in the system. It's not the platform. It's the code that we wrote in our application yesterday morning. And so the platform has absolutely no opinion about that code. It's completely up to us to decide what the quality requirements are for that. So, coming back to this book, about half of this book is about this idea called quality attribute scenarios. And I thought we probably need a new way of thinking about user stories for quality purposes. And I remembered this from that book. So we'll go through a few of these. We'll start with the abstract idea. You've got an artifact, and the artifact could be code or a system, and there's an environment in which the artifact is found. So for example, normal operations for a microservice, or the developer's laptop for some code that's being written. And then you have a source, which is kind of like an actor, and the source comes along and stimulates the system in some way. And then the requirement is expressed in a response, so the desirable response to that stimulus, and perhaps a measure to make sure that we've achieved the desired level of that response. Pretty abstract. So let's look at some textbook examples. So imagine a server running in a data center somewhere. It's under normal operation and it fails. So what's the response that we would like? We'd like the system to be informed, the system to inform the operator, and the system can continue to operate, and ideally there's no downtime. Maybe it feels a bit old-fashioned, but the cloud has similar things. A modifiability scenario. So if somebody's working on a user interface that wants to make some changes at design time, they can make the change quickly, in less than 3 hours, and the change can be made and tested, and there aren't any side effects. Easy peasy. Of course, obviously, we all do TDD, right? So when we do this, we're working on code in the development environment. The developer completes some code, wants to run some tests. The tests run quickly, 85% coverage, maybe. And it all happens within 30 minutes. So that's a testability requirement. And finally, a performance requirement. So there's a system running in normal environment, normal operations. 500 users come along and want their metric results. They send 2,000 requests, and we expect all the requests to be handled, and for an average latency of 2 seconds. So pretty modest performance requirement. A lot better than what we did with the metric results app. So those are textbook examples, and then I thought, let's work through a few more on our own, because this is kind of an important idea in this talk. So imagine the neighborhood teenage dirtbag is coming along and attacking us with a SQL injection attack. So we've got an online shopping app, normal operations, teenage dirtbag comes along and attempts a SQL injection attack. So attempts to steal our data with a SQL injection. So what's the response we'd like? We say, go away, teenage dirtbag. Here's an error. And we log the request so that we can understand how we've been attacked over time. And this is always the hard part. And I struggled with this again. Response measure. So in the context of this system that I'm imagining, no database query has been executed, but maybe there are different response measures for different systems. Remember the banking service that kept me awake all night? So I thought of some fairly modest requirements that could have saved me a lot of time and hassle 25 years ago. Imagine the banking service is running under normal operations, and we have a software error. There's a bug that we hadn't picked up yet. Causes the service to fail. The response is, we log the error, we notify the operator, and I don't have to drive across Joburg, something automatically restarts it. And the response measure is downtime is less than 1 minute. So again, a fairly modest requirement. In this one, let's go back to the mobile app. And the customer comes along, adds an item to their basket. It's the in-store system, so that's the mobile app and the backend services all working together. And let's come back to the environment, because I think that's important. The item appears in the basket, and it all happens within 1 second. We got a lot of things right on this project. So we didn't go straight into production with paying customers on day one. We went into the stores. Well, I wasn't there, but my colleagues went into the stores and did the shopping themselves so they could understand how the thing worked in production. But we imagined the environment. We weren't explicit about this, but we imagined it was some kind of lab or some kind of artificial environment in the cloud, and we didn't explicitly say the environment was the cloud, was the store. I'm not sure we would have done any better, but at least we would have had a chance of saying, let's go to the store, test early on before we even develop the app, just to see what kind of network we had there. So we finished with those things, but they're very specific, and we make them very attainable. So we don't say we want 5 nines availability. We think one by one about the things that might compromise our availability, and we address them one by one. And this makes it attainable for the team, because we're saying we've got not addressing every single unknown attack on our availability. We're thinking about one thing, and we're thinking about how to design for that one thing. We're thinking about one kind of security attack at a time. Things like testability and modifiability might be a bit more cross-cutting, but there's a way that these things feel much more attainable one by one. And once you've done a few of these things, you realize there's nothing obvious about this. Nobody's going to be bullying you with obviously anymore. So about 15 years ago, we started a project with a vision. Our vision was we had to consume a lot of data, so multiple gigabytes per second, and we called it drinking from the fire hose. And at the beginning of the project, we got together for 3 whole days and worked through those things. They were cursing me in my book after 3 days, but we came up with a whole lot of quality attribute scenarios in those days. And we set free this burst of energy that lasted for about a year. It was probably the most exciting year of my career, because we had all these non-functional requirements, all these quality requirements that we'd never had before, and we could obsess about them. So we eliminated single points of failure. We tested our code for performance over and over. We optimized, and we kept on making it better and better, more secure, more available. And at some point, we had to let people use it. And the people that were using it were our colleagues in the same company. And we developed our own API and query language, which we inflicted on them. We'd kind of neglected the one job, which is to say we collected all the data, but we didn't make it available to our colleagues in a way that they could consume, and they rejected it, said they're not using it. So I was lucky enough last week in Stellenbosch to bump into my friend and former colleague, Walter Schulze, and I asked him if I was being a bit unfair with the story. And Walter responded by sending me a query in the language. So this is a query. I don't even know what this does. And he reminded me that only one person in the world could write a query in this language, and that was him. And not even he could read them. So he said I wasn't being unfair at all. But he realized that we had a problem to solve, and he worked with our customers in the organization. They worked very closely to understand the usability requirements and to address them over time, and to make a much better API and a much better query language. It wasn't too late. And that's point number 4. It's not too late. So no matter how old the code base is, no matter how mature the product is, it's not too late to think about these things and to make the system better. So last year, I joined a team that had been working on a code base for about 5 or 6 years. It was very mature. It was a performance test, as you can see in the picture. And it had many, many features and was a very mature product. But when I came along, the first thing I did was clone the code from Git and try to get some tests running. And I struggled. So I spent a few hours doing that, many Slack messages, many Zoom calls later. I eventually tweaked the configuration and got the tests running. And I made notes along the way. So then I went to the product owner and I said, hey, I've got this talk coming up for DevConf. Can we do can you give me another story to tell? Can we do some quality attribute scenarios? So he graciously agreed. And we got together and we thought about the usability of the system, and we wanted somebody to be able to get up and running with the code within a few hours. So we obsessed about that for a while, and then we thought about testability. So this test was running in production. It was seldom run in the test environment, and so we got some kind of unexpected results every now and then in production. So we decided to make the test in the test environment better. And so we did those 2 things, and it took us a couple of weeks, and we did them. And then we talked about having another session. I wanted another story to tell for DevConf, but it never quite happened. We hadn't really succeeded in building this into our routines. And that's probably what we need to do if we want to embrace this kind of thinking in Agile. So I was thinking about what the routines are. Something like this. There's a magical process by which we generate stories, then we prioritize them, and then we go and build, and we deploy, and we observe. And when we observe, maybe we get customer feedback, maybe we see performance that isn't as good as we would like. We feed that back into the story generation process, and we generate more stories. So how can we do that with this kind of user story, this quality attribute scenario? So the starting point for me is always worry. I wake up in the middle of the night and I'm worrying about something. I think we've got an opportunity for a buffer overflow attack from the local teenage dirtbag. So I write it down in the middle of the night, try not to wake my wife up, and then worry about the next thing. And if we do that, we have an opportunity to measure whether that thing happens. We go read the code, we go and run some tests. And if we decide, okay, there's a very real problem here, we can generate ideas and develop the scenarios. We can also observe. So we can just see there's performance that's poor. We can see there is modifiability that isn't as good as we'd hoped for. We can use that to generate ideas. And if we're desperate, we can go back to those checklists. Once we've done that, we can get together and workshop the scenarios. We can develop them in the way that we did on that other project. And we can get together, consider the trade-offs and interactions between the requirements, and we can prioritize. And then we can go back into that cycle of developing and testing and deploying and measuring. So the design and implementation, this is the interesting part. I don't know about you, but I love working on these things. This is really challenging work. It's exciting. It's difficult. And most of the time when I've had opportunities to work on these things, I've really enjoyed them. We've run out of time. So that will be next talk. That's to be continued. In the meantime, you have one job, which is to think about these things, start talking about them in a different way, unless you're already doing this and just wasting your time here this afternoon. And then maybe you'll get to a point where you get the excitement that I've had, where you have good requirements, and then you can go and design and implement for them. So we've come to the end. The key points that I hammered on were, if we don't take quality requirements seriously, we may not have a product worth building. There's nothing obvious about them. We need to be deliberate. We need to think carefully about them and work as a team. And that's the next part. We as developers can't afford to say it's not our job. We have an important role to play in this. And I guess it's hard also to go and convince people to start thinking about these things. Only the best way to do it is just to talk about it and to say, maybe we have a problem. And then no matter how old or mature the code is, no matter how dated the code base might be, it's never too late to think about these things. And we use the name quality requirements. We probably want to reject the name non-functional requirements because of the way that it makes us think. If we do this kind of thing, maybe we'll be less dysfunctional about non-functional, and we won't be leaving quality to chance anymore. So it's a QR code for rating this talk. Please go ahead and do that. And then we have quite a bit of time for questions. Yes?
I'm just curious. A lot of the information you gave is pretty applicable in Agile.
Yes.
What kind of advice would you give if you're involved in an old school waterfall project where requirements were built completely functionally and the timelines were decided, and then these non-functional requirements start coming to bite you towards the end? Like how do you approach that kind of conversation when there's projects involved kind of timelines?
And obviously it's come out, right? So the question is, for the recording, in a more waterfall process, we've now completed the project, and now there are quality problems. How do you go about addressing that? Did I get the question right? Yeah, it's a really hard one. I guess stop doing waterfall. So I think then, I guess it comes back to that thing of never being too late. It's never too late to go and understand what the problems are and to start thinking about them as requirements. And then, the waterfall's hopelessly late at this point, I guess. So the only way is to feed back into the waterfall and to say, we missed these requirements. We often do that with waterfall. We say, we got the requirements wrong. We have to go back to the requirements phase and build something new. And this is possibly not an exception. So we would say, let's analyze the requirements, let's design for them, let's implement and test. So we kind of have to do another waterfall cycle. Does that help? Agile, yeah, so Agile with very long iterations. I think there's no way to save that waterfall plan, is there? It's too late now. You've got poor quality at the end of a waterfall process. Who would have thought? And obviously, yeah, thank you. I missed that opportunity. Another question? Any questions? Cool. Refreshing beverage time. Thanks very much.